Implication. The symbol that looks like an arrow pointing to the right represents the English words if, then, in that the symbolic statement P arrow Q, or P implies Q, can be read as if P, then Q. We're familiar with implications. For example, if Kim is caught speeding, then she will receive a ticket, is an implication. We call P the hypothesis and Q the conclusion. In the case of speeding, Kim is caught speeding is the hypothesis. And the conclusion is she will receive a ticket. The conditional statement P implies Q has a false value only when P is true and Q is false. And it's very unique, but false value only occurs when P is true and Q is false. Let's take a look at the truth table. So in the truth table, we have our standard P and Q columns. And in the first row for P implies Q, if P is true and Q is true, then we have true. If P is true and Q is false, then we have a false statement because we only have a false value when P is true and Q is false. In the third row, P is false and Q is true. We automatically have a true, and if we have false, false, it's automatically a true. Kind of as a side topic, if there is many operations or symbols, there is an order in which to approach them. The not symbol is approached first, then the and, or, and lastly the implies. Now, if there is a grouping symbol, you do approach the items in the grouping symbol first. Let's take a look at the implication being applied to computer language. In programming language, if and then are used frequently, instead of an arrow for implies. Let's take a look at an example. The example says, use the program to determine the value of C for the different input values of A and B. So A and B are going to be what we call independent values. They're ones that we're going to put in. And the result of those values then tells us what C will be. And so C is a dependent value. All right, let's take a look at the situation. It says if A times B plus C, if that result is greater than or equal to 10, then the value for C is A times B. But if the original statement, A times B plus 6, is not greater than or equal to 10, we hit the else let C equal 10. Let's take a look at the first situation. So we have A equals -2 and B equals -7. We're going to put that into our if statement. We have -2 is multiplied with -7, and we add 6. We want to know if it's greater than or equal to 10. Well, we have 14 plus 6. Well, that's obviously greater than or equal to 10. So since it is greater than or equal to 10, it is true. That tells us then let C equal A times B. So C will equal A times B, which was -2 times -7. So C equals 14. In part A, that is the answer. Part B, this time A equals -2 and B equals +3. So we have -2 multiplied with 3. I'm going to add 6 to it and see if it's greater than or equal to 10. So -6 plus 6 greater than or equal to 10. Well, I end up with 0 is greater than or equal to 10. That's false. Since it's false, we don't use the then let. Instead, we use the else let. It means automatically C will equal 10. Part C. A equals +2 and B equals +2. So 2 times 2 plus 6 is greater than or equal to 10. Let's find out if that's true. 4 plus 6 is greater than or equal to 10. And we have 10 is greater than or equal to 10. Now notice it's or equal. So 10 does equal 10. So this satisfies the statement. This is true. We're going to go up and use the then let. We let C equal A times B, which was 2 times 2. C will equal 4.